Okay, then we'll crack on. So, firstly, I'd like to thank our good friend Richard Hicks for joining us again for another webinar on AOVPN and DPC.
Thanks for having me, Leo.
My pleasure. And for those of you who don't know, my name is Leo Darcy. I'm the secure infrastructure workstream lead at Power and Platforms, and I'm also one of the kind of primary developers of DPC.
And for those of you who don't know me, my name is Richard Hicks. I'm the founder and principal consultant at Richard M. Hicks Consulting, specializing in broadly in enterprise mobility and security infrastructure. Do a lot of work with secure remote access and certificate services, PKI.
Lovely. So today we want to do something slightly different to the kind of the webinars that we've done before. We want to talk about some of the issues that both Richard and I typically see around AOVPN and their kind of implementations, and then kind of talk about some of the ways that you can solve them both without DPC and also how we believe it's significantly easier with DPC.
That should be readily apparent at the end of the webinar for sure. And by the way, this is by no means a comprehensive list of problems that we encounter with Always On VPN. No. It's kind of got the 1 hour ones, maybe. Right, exactly. We only have 1 hour. We'd have to do this for a week. But yeah, we kind of just cherry picked some of the most common ones that we get questions on, and that when we're working with our customers, we see these challenges. And so we thought we'd just kind of make a top 5 sort of thing and talk about how how we solve these, without DPC, and then how DPC makes that much easier, as you'll see.
Yeah. So for those of you who aren't aware of DPC or don't maybe know what it is and how it works, effectively it acts as a middle layer between the always-on VPN configuration on your device and your administrator. So it effectively acts as a graphical interface over the top of the XML configurations that you may be familiar with. And that allows us, or it allows administrators to be to use a more usual, and it allows them to use group policy or Intune management to apply AOVPN configuration, as opposed to needing to delve into the horrible XML funness that is the default configuration.
100%. And by the way, when I was first introduced to the solution, you guys reached out to me about this, and I thought this is fantastic. And I thought it was it's a fantastic solution. Obviously, you guys were receptive to adding features and functionality at my request, so thank you again for that. But I was kind of disappointed initially because I thought, we're kind of going towards Intune, and this is such a great solution that it wasn't going to work there. And then of course Microsoft comes up with this concept of, hey, we can use your own custom ADMX in Intune, and that was it. That was fantastic. At that point, DPC became the way to go. I love the fact that you can use it for on-premises Active Directory and group policy management, but yet you don't lose anything if you decide to move to Intune management. You can still push the software out with Intune, push the policies out with Intune, and then you get all the advanced features and functionality without some of the pain that even Intune imposes. So it's going to be great.
Yeah, so one of the main advantages that we have with DPC is that it's actually an agent on each of the devices, which means that we can do things that the Windows kind of CSP teams behind the scenes just haven't enabled yet, or will ever enable. So that allows us to actually have some more functionality than even the Intune interface for it, because they're kind of reliant on the CSP backend interface for their functionality.
You're absolutely right. You bring up an excellent point, right? So with Intune, there's the native VPN profile for which you can walk through, check the boxes, enter the values, and it's a wizard-like interface, right? Of course, that doesn't expose all the features and functionality that is in the underlying CSP. So we have to use XML to do that. Creating the XML file by hand, for anyone on the call who's done this before knows that that's tedious, time-consuming, and error-prone. And so that's a challenge to get to work correctly. And then even past that, there are still settings that we need to adjust post-deployment that are not even exposed in XML. So all that functionality we've built into DPC. So once DPC runs and imports the XML, it does additional fine-tuning and optimizations over and above that, so that you get a very robust always on VPN client configuration setting out of the box.
So appreciate that we're only going to talk about kind of 5 key challenges today, but if you do have any other questions relating to DPC or AOVPN at all, then please do drop them in the chat, and we're aiming to have quite a period of time at the end for Q&A, although based on past experience, we may, or we both have a tendency to take too long on these things, but please do drop your questions in the chat, and we will try and prioritize that at the end.
Sounds good. We'll be more mindful on this call.
Yeah. So VPN strategies. This has sort of been the bane of many people's lives for a long time, hasn't it?
No question, no question. And just as a brief overview or introduction to the VPN strategy setting, with Always On VPN, there are multiple supported VPN protocols. Practically speaking, there are really only 2. Those are the IKE-v2 Internet Key Exchange version 2, which is an IPsec-based transport, runs on UDP. And then there's also the Secure Socket Tunneling Protocol, or SSTP, which is a TLS-based protocol. HTTP-based protocol uses TLS for security. The advantage to using IKE-v2 is that it performs well. It has the ability to be very secure out of the box. It is not from Microsoft. It is very secure. You have those options to change those settings in DPC or in the UI or in CSP as well. Bottom line is IKE-v2 is a pretty robust protocol, but it suffers from a number of operational challenges and limitations. It's not very firewall friendly. UDP always struggles with NAT, and there are some unique challenges to IKE-v2 when it comes to NAT, and so there are a lot of stability and operational issues, limitations, and challenges with IKE-v2. SSTP is a fantastic protocol. It can be very secure with minimal configuration, additional configuration. The advantage to something like SSTP is it is very firewall friendly. It runs over the standard HTTPS port, port 443. So it's ubiquitously available. It always works. It always functions. So we have customers who say, well, I would prefer to use the highest level of security and then fall back to SSTP if that's not operational. And Microsoft allows you to do that. The protocol setting is technically called automatic. The problem that we run into is that when you select automatic, out of the box, it will try SSTP first. And so, well, there aren't any real scenarios in which, SSTP wouldn't work. So I'm probably just going to use SSTP all the time. If you set it to IKE-v2, it will use IKE-v2 all the time. So there's some real problems there. Also, Microsoft overwrites the settings. So the VPN strategy setting is actually contained or included in a configuration file. It's called rasphone.pbk, and you may have some experience with that. There's basically just a setting in there that you can set to change that strategy, and you can prefer IKE-v2, or you can prefer SSTP, or you could do IKE-v2 only or SSTP only. And so that setting, unfortunately, is not persistent. Windows can overwrite that. And so there's been a lot of problems with that. So the way to fix that was edit that INI file or that PBK file. Easy enough to do technically, but at scale, some real challenges. So we've written PowerShell scripts. I have detection and remediation scripts for Intune and proactive remediation. But all of those things must be done post-deployment, and you at times will suffer operational challenges until those remediations run, and of course, the connection restarts. So it can be done, but as you can see that it is a bit challenging to get done. It is much easier in DPC, and Leo, if you will demonstrate that for us, that'd be fantastic.
Yeah, so we'll just jump onto here. So here's the settings on a domain controller in group policy. You can obviously set these in either Intune or locally on a device for things like testing and development, that kind of thing. And then under the user tunnel settings advanced, you'll see this VPN protocol option. And then rather than having to understand the differences between each of the numbers that Microsoft have given things behind the scenes,
good point, yeah.
What we've done here is just given you the actual English of what that would look like. So in this case, we've actually got it set to IKEv2 first, SSTP fallback. Although you do then have the options to limit things to either SSTP only, IKEv2 only, or SSTP first with IKEv2 fallback. So we can kind of do all of the major ways and options.
Good point. Yes, veteran Always On VPN administrators might be familiar with the numbers. You and I probably certainly are, right? We set it to 14 or 7 or 5 or 6 but yeah, those numbers are not going to make any sense to most people. So absolutely having those in plain English was fantastic.
No. And also those the version that is actually online is not actually the most up-to-date version. To get the actual latest list of those numbers, you actually have to dig into the Windows SDK, which is not somewhere that many people want to go. Good
point. And that's right, because the Microsoft documentation for that is woefully outdated, right? The public documentation for it.
I think it's mostly from the Windows Server 2003 resource kit.
I want to say SSTP wasn't even in there, or I don't even remember. But yeah, my information that I got was from a Microsoft escalation engineer many years ago, and I'm like, hey, where'd all these numbers come from, right? So yeah.
Lovely. So if we move on to the next one, which is interface metrics. So it's a brand new blog post out from Mr. Hicks for those of you who haven't checked Twitter today.
Yes. So the interface metric is a setting that we have been dealing with for a number of years. Yesterday, preparing for the webinar, Leo and I were having a conversation. And he says, "Hey, I don't see a reference to like an article about the interface metric." And it kind of dawned on me. He said, I really haven't written a post specifically on that. So fortunately enough, I found myself with some free time yesterday when a meeting canceled, and got that documented and published to the website. So I feel better today, so we can talk about this. And there's a reference to that as well. So the links are, how are we sharing the links, Leo? Are we sharing those
just
live in the Q&A?
They're published in the Q&A.
Okay, fantastic. So for those of you on the call, if you wanted to take a look at that, you can find that link in the Q&A. But the high level overview of the interface metric is that interface metrics are assigned by Windows, and they're used by the operating system to determine how to send traffic and receive traffic, how to route traffic, right? So if you have multiple active interfaces, and that's the key, the metric is really important. The metrics are assigned automatically. And they are assigned based on their properties. So the interface type, the interface speed, a variety of other factors, and they're assigned a number, and the number with the lowest priority or the lowest value is preferred. Okay, so you can see that information on your machine by just typing in get-net IP interface, and you'll see those are the kind of the automatic values that are standardly applied, right? So Ethernet interfaces are typically 25. Some interfaces will be higher, some might be lower. So herein lies the problem. When we have a VPN connection established, we have two active interfaces. We have our VPN interface, which is connected to our on-premises network, and we have whatever interface we use to connect to the internet, whether that was a Wi-Fi connection or maybe it was a wired Ethernet connection. The real challenge here is a scenario in which you are using split DNS. This is the most common when I see this, but it can happen if you're not using split DNS. But split DNS meaning you're using the same namespace internally and externally. And then you are using a cabled or wired connection. In other words, a Wi-Fi connection probably doesn't have the issue as much, but if you're using a cabled, like somebody's plugged in with an Ethernet cable directly into their cable modem or their router, this is where the problem lies. Oftentimes what will happen is the wired Ethernet connection will have a same or lower interface metric as the VPN tunnel, and it can yield unexpected results. And what might happen is a DNS query, instead of going to the on-premises network, will use the adapter that's connected to the internet. Well, if you're sending DNS queries to the internet, they're not going to resolve your internal Active Directory names. And if they do, I'm pretty sure they're going to be incorrect. So you might get NX records back. Or in the case of split DNS, you might have the same resource, internal and external. mail.example.net resolves to a private IP internally, but a public IP externally. And so it can cause real problems. So once again, to address the issue, we just need to update the interface metric. Easy enough, right? We can set that in PowerShell. And the challenge with setting it in PowerShell is, one, it's difficult to scale. Two, it's not permanent for the VPN tunnel interface. If you set it on a physically connected interface like a Wi-Fi adapter or an Ethernet adapter, it's persistent. But for the VPN tunnel interface, it is not. So unfortunately, what we have to do is we have to go back to that INI file that I told you about before. And this is what we were talking about at the outset of the call, is that there are settings you can change in the Intune UI. There are even more settings that are exposed in the XML, but yet this is one of those settings that's not exposed in either. And so we have to do it post-deployment. So in order to do that, it's the same thing. We have to edit that INI file. I have PowerShell scripts available to do that. I have proactive remediation scripts available in GitHub. In fact, if you're interested, I have a GitHub repository with many scripts. But once again, Leo's going to show us how it's just a checkbox in DPC. We've taken care of this for you, and it's super, super simple.
Yes, so the the reason why the interface doesn't actually persist, or the reason why the interface setting doesn't persist, is actually because the interface doesn't persist. With the VPN adapter, it only creates the interface at connection time, which is a little bit funky.
It is technically a dynamic interface, correct? Yeah.
Yeah. So to set that the interface metric on a VPN tunnel, what we can do is we go in. It's again under the advanced settings. We've got VPN tunnel metric, and by default it sets it to 15. But we can easily drop that down as low as down to 1 if you want. But I think
can set it to 1.
Most
right?
common is 3. People use.
So. And most common is 3 only because that's what I've been using.
Yep.
Because all my samples show 3. I do have some peers that are doing a lot of Always On VPN work who set it to 1. I've been setting it to 3 for years and have never had one bit of problem. It always solves our name resolution challenges. Doesn't seem to cause any other unintended consequences. So I've just kind of stuck with that. But at the end of the day, it just needs to be something lower than any other interface that will be on the machine. And Ethernet interfaces tend to be 25, but I think I've seen them set to 15 before. I don't know if somebody manually set them. So I just push it all the way down to almost the bottom, and have had good luck with that. So
yeah. And there is one other way that we've found to handle that. If you don't want to go, if you don't have DPC, you don't want to go to the trouble of scripting it all. You can actually disable the smart DNS resolution, which then goes through them. I believe it's 1 at a time or something like that. And there's another link that we're going to drop in the chat to do that piece. We generally don't recommend that approach if you can go down other ways of doing things, because it does have implications both on VPN and off VPN as well. But it's also useful to know if that you can't go down the other options.
And that was smart multi-homes name,
yes,
DNS name resolution, I think is the policy if you're looking for that. Yeah.
Because in Windows 10, they basically rewrote the way that DNS resolution works to no longer kind of be a very statically assigned list of DNS, and it kind of goes out to everywhere and sees who comes back first. But also there's some metric stuff involved, which just kind of stirs the pot in terms of you'll probably get DNS resolution from somewhere. But in this case, we very explicitly want it from a specific place.
Not from where you need it to be. So
exactly.
Absolutely.
Lovely. So namespace routing. So the naming of this actually confused me when Richard first kind of coined the term to me. So do you want to just kind of explain what you mean by namespace routing? So
namespace routing, or routing as we say here in the United States, namespace routing is the concept of it's a parallel to IP network routing, right? Where we define a route. This route says the 10.0.0.0/8 network goes over this interface. That's like an IP route. A namespace route would be star.example.net routes over the tunnel, or mail.example.net routes over the tunnel. So one of the things for anybody on the call who's familiar with the direct access, this was really, really simple because direct access used the name resolution policy table, but it also used IPv6. And so with DNS 6.4 and NAT 6.4, when you made a request that was in the NRPT, it would send it to the direct access server and you would get an IPv6 address back, a synthesized IPv6 address back. So you could say, some public website, www.example.net, I actually want to resolve over the tunnel. It would get back an IPv6 address that maps to the public address, and then I would route that over the tunnel because that IPv6 address was routable only over the direct access tunnel. So namespace routing also, I refer to it sometimes as selective tunneling. So that's maybe a more accurate term. But principally speaking, what we're doing is we're taking some external properties, public websites, and routing them over the tunnel for whatever purpose we need. The most common scenario would be I have a SaaS application in the cloud, but it is ACL'd to my on-premises network. So you have to be in my building within my four walls, going out of my internet egress at my organization's physical address to be able to access the application. So if I access it from the internet or from a non-managed machine or what else, then it doesn't work. So in that case, if I have users who are field-based and they're connected via Always On VPN, I need them to take that particular namespace, route it over the tunnel so that they can get to the internet and appear to be coming from on-premises. But I don't want to do forced tunneling. So if you did forced tunneling, it'd be really easy. Everything comes over the tunnel. You don't have anything to worry about. But in the case of selective routing or selective tunneling or namespace routing, what we want to do is say, hey, we want to do we want to do split tunneling. So all of my regular internet traffic just go to the internet. I don't want to bring that over the tunnel. But this particular property I need to. So www.example.net or app.example.net. So the challenge with Always On VPN is that I can very easily tailor where my DNS queries are sent. In other words, I could send the name resolution request for that namespace over the tunnel. The challenge is that Always On VPN uses IPv4. So what it's going to do is just going to give me the public IP address back, right? And then it's going to go directly to the internet. So I have routed the name resolution request, but I can't route that over the internet. Now, the quick and dirty way to fix this is to add those public IP addresses to the routing table. So if it's a simple IP address or two, awesome. I can actually add those to my routing table and fix that. The problem comes from when you have websites that are using dynamically changing IP addresses, or you have websites that have many, many addresses. So those become really problematic. So what you could do is do a resolve DNS name or NSLOOKUP or dig, whatever you want, get all the IP addresses, put it in the routing table, and guess what? When it changes, you're gonna have to go back and touch all your clients again. So that's really problematic. Always On VPN does not natively have a way to route namespace. I can't do that like we did very easily in direct access, but Leo came up with a very clever way to do this. And Leo, if you would explain your solution to this. Well, actually, before I proceed, the other way I solve this is actually to build a proxy server infrastructure. So I've actually helped the customers stand up proxies on premises. Typically, you just use Squid running on Linux. Although it does run on Windows, you can port it. You can use one of the Windows ports. And then what we have to do is we have to host a proxy auto configuration file or a pack file. And then in that pack file, we say if the namespace matches this, route to the proxy, and the proxy is reachable over the tunnel. So obviously there are ways to approach this, but again, Leo came up with a very clever way to do this and make it kind of functional and manageable. So if you could enlighten us.
Yeah, sure.
Leo, that'd be great.
So we'll use the example of bbc.co.uk because that's a relatively good one in terms that it's got multiple addresses that it will resolve to. And ultimately, as a as Power on platforms, we have zero control over what the BBC do from a public IP addressing perspective, and they do not guarantee that these will be the only IP addresses ever used. Which we could, just take this list, statically assign it in our route table and hope for the best. But ultimately, I can pretty much guarantee you that these will switch out, and therefore you'll start getting weird inconsistencies when trying to talk to bbc.co.uk. You might get some support cases of like, oh yeah, this site's broken or slow or any number of other things. So it's much better to do this stuff dynamically. So what we've got in DPC now is we've got this option of allowed routes from DNS, and we can go in there, edit that, and we can actually add in the site, and you can just add in a comment as well. So what that's actually going to do is it's going to that gets sent down to the client, and when the DPC agent attempts to build up its route table from the other configurations, it will then take the DNS route list, it will do an NS lookup on it at client runtime, and then generate the new profile or add that into the route list dynamically. So that's got a couple of advantages from a kind of both from a user experience and from a administrative perspective. The first one being is that DPC generates its profiles typically on an hourly basis, although that is a configurable setting. So should the BBC change their IP address list in an hour's time, depending on how much they change that list, you could get a little bit of a few issues during that time. But ultimately, within an hour, all of your DPC clients are going to pick up the new set of DNS. They're going to rebuild their IP address list. Notice that the currently installed profile is different from the new profile because the BBC IPs have changed, and therefore will change the connect or the deployed tunnel to the end users without the administrators even needing to be aware that the BBC have done that. This can also be a useful, the classic case is those AWS websites where the whole of the AWS namespace is just, or Azure or any of the cloud providers, is just ridiculously huge. And customers have like even the people using those systems, unless they go and explicitly pay for static IP addresses, they have very little control over where their IP addresses are going to be. So that can cause some issues at some times. Now, there are limitations to this approach. The key one being that fundamentally behind the scenes, this is just an NS lookup. Therefore, the actual IP address in the root list needs to be resolvable. So that classic case of, oh, I want to put all of my Windows updates through it. And now if you go look at the update list for Windows Update, it'll be star.windowsupdate.com. And unfortunately, we just can't handle that, because the only way to handle that would be to start doing a kind of brute force attack of like a.windowsupdate.com, b. etc.
Yeah.
And that's just not feasible or functional. So it does have to be a resolvable address. And the other thing is that the clients do need to be able to resolve that IP address or those or that traffic. If it can't resolve it at the point of the generation, there is a fallback mechanism where it caches the last known good version, and it will continue to use that until it can re-resolve it, and it does put a warning in the event logs. But fundamentally, if the client, especially on the first launch, can't access or can't resolve that IP address, then it's or that address DNS2 IP address, then that client won't have that IP address in its root list until it is able to successfully resolve and update that list.
Awesome. And I remember when you added this feature, I thought this is very clever and going to be very helpful, although not perfect. But I think it's a lot better than nothing at all. So I think it's going to be really helpful. I have a couple of customers using this and no complaints yet. So it's been good.
Yeah. And then the other thing I kind of wanted to mention in this section is that for organizations that have a set of known IP addresses that they do need to bulk add, classic case for this. Oh, actually, no, sorry, I'm skipping ahead there. Ignore me. We'll come back to that in the next section.
Good deal.
So on to the next section. Office 365 exclusions with forced tunneling. Now, this was a very interesting Microsoft post that they released at the beginning of COVID, wasn't it?
No question. So a bit of background on this. So when you set up a VPN connection, not just an Always On VPN connection, but any VPN connection, you have the choice of enabling split tunneling or forced tunneling. So split tunneling is very simply, we're going to send traffic over the VPN selectively, right? So we define specific routes to go over the VPN tunnel. Everything goes out. Everything else that's not explicitly defined in the routing table goes out directly to the internet. And so very commonly with split tunneling, we say, here's what our internal private networks are, and we add those to the routing table, and then everything else that is not in that routing table goes to the internet. So your file servers, domain controllers, SQL servers, SharePoint, anything on premises that's in your private network would be in those private address spaces that you route over the tunnel. Everything else that's on the internet with public IP addresses would go out the internet. And that's the generally accepted best practice for VPN today. Historically, it wasn't. In the early days of VPN, it was common to do something called forced tunneling, which meant when the VPN was connected, bring all the traffic over the tunnel, even the internet traffic. There were some compelling reasons to do that in the 90s. Today, perhaps not. I don't know, Leo, if I have an article about split and forced tunneling that I wrote because I answer this question so often. So I wrote that because it was just easier to refer to a blog post about that. But there are compelling reasons for both. At the end of the day, we recommend split tunneling, but understand that this is a design decision that administrators have to make. So when the real challenge with forced tunneling is that it is heavy-handed. It does bring all internet traffic over the tunnel. And again, maybe in the 80s and 90s that was acceptable, but today we have so many applications and services running in the cloud that are publicly available that force tunneling it is challenging, because now it's just a lot of traffic. It's not just some light internet traffic to a website for some news or mail, webmail or something. There's a lot of data flowing over that, and so it became really problematic. It's force tunneling introduces basically it's a suboptimal routing path. You have a lot of protocol overhead and encryption overhead. All of those kind of conspire to make a rather poor experience for the user. So Microsoft introduced this concept of exclusion routes. So in other words, this is like previously we talked about selective tunneling, where we wanted to route some internet sites over the tunnel. This is the reverse. So in a force tunnel scenario, I have some sites that I don't want to force tunnel. And so you basically create a route, and in that route, you define it as an exclusion route, and it will be excluded. So essentially, if you're trying to get to that property, everything's going over the tunnel, but if you match that route, it will be exempted from the VPN. It will go directly to the internet. And in this scenario, Microsoft realized that shortly after the COVID hit, that many of their customers were complaining about poor performance to Office 365, and so they came up with this technology. They pushed that out, and then they published a list of IP addresses for Office 365. And as you can imagine, there's a great many of them. And by the way, they change all the time. So you can query these. Then Microsoft puts them on the internet. There's a web page. You can see them. You can actually do it programmatically, because you can pull this down with JSON and so forth. The challenge, of course, is that if you're doing this in Intune first in Intune, there is no support for exclusion routes, so you have to do this with XML. And if you're doing this with an XML, you have to populate those routes. And of course, when they change, you now have to go back out and touch the client configuration. So once again, Leo and his team have made this greatly simplified. So Leo, if you could explain your solution for that.
Yeah, so just showing on the screen here, this is the Microsoft published script for going through and amending all of the Office 365 routes into your tunnel.
Just a quick script, huh?
Yeah, not a particularly pleasant one in any stretch of the imagination. Yeah. So what we did was we effectively do something very similar to the way the script works, but we've embedded it again in that client configuration. This is one of the very few times the DPC agent actually needs to have outbound connectivity to the internet, and specifically to the endpoint, the Microsoft URL endpoint. And so to enable this, we just go in, we tick that box, and we hit OK. And that's all you need to worry about from a configuration side, apart from that client connectivity perspective, because just with the DNS resolution. Again, each of the clients will be going out, talking to the Office 365 endpoint, downloading that list of currently published IP addresses, and then amending all of those into the exclusion route table. So this is only valid as part of a force tunnel scenario. If you try and set it while you're in a split tunnel, I believe it just ignores it and it gives you a warning saying this is an invalid configuration, but just carries on as normal. Mainly because if you're already doing a defined split tunnel, then there's no point in having the forced or the exclusions in there, because they shouldn't be overlapping anyway.
Sure. Yeah.
And again, the other thing to note is that the exclusion list from Microsoft is very large, very broad, and does not completely interface well with AOVPN. So you'll see here, for example, again, we've got like outlook.office.365.com. Because that doesn't interface with the route table directly, those elements get ignored. So it is only the IP CIDRs that get included in that list at the moment. So it is not perfect. but it is a lot easier than doing it through the Microsoft perspective, and you likely get a much better performance than if you just didn't exclude them at all.
I 100% agree. Absolutely.
So the other thing I did want to mention at this point is that we've had this question come up from a couple of customers of, oh, can you do a similar thing for, say, Zoom, or for I can't remember the other ones, but yeah, or like basically I've got this giant list of exclusions that I really want to add into my into my DPC configuration, but that could potentially update or something, or I just don't want to go through and type in 200 CIDRs manually. And for that, I hear you.
Yeah.
I've done 10 or 20 before, and it's just pretty miserable. It's again doable, and but especially if you need to like do that update. But what we don't want to do at kind of Power On is be the bottleneck on that stuff. And also, every time we add a feature in like this, there's a lot of ongoing maintenance to keep it up to date, potentially, as the APIs that these various companies use could potentially change, and then we need to kind of re-interface with those. So what we've done is we've actually created a more generic solution, which is available from, or it's effectively a script that you can kind of customize yourselves, which is available. The link for that should be being published now. But it's available through our support website, and effectively we're making use of the fact that the configuration is done via group policy. Oh, there we are. Sorry, I thought I was logging out there for a second, but it looks like just my Azure Virtual Desktop session. But yeah, effectively what this is doing is we've got a PowerShell script that just looks for a file that has a list of IP addresses or CDRs in it, and that can be either on a file share, on a website, wherever you want to kind of update this script to go to, you can do it. And we're using the Zoom ones as an example of this. And then what it's doing is it's using the group policy PowerShell commandlets to go in and interface with that group policy to set to automatically bring all of those in as well. So it's a more generic approach that should hopefully suit a lot of customers' needs, where it's not the Office 365 routes that they want to exclude in this way.
Outstanding. Excellent.
And on to the final one, the device tunnel status in UI.
Yes, this is a common question that we get. So the device tunnel, just as a bit of background information, Always On VPN is really designed to operate at the user level. When it was first introduced, there was no device tunnel. The only thing was the user tunnel. So many customers pushed back and said, we need a device-based connection because we are hybrid Azure AD joined, or we're just on-premises AD joined, and we need that pre-log-on connectivity to support logging on without cached credentials. We ship new devices to users in the field, and they have to be able to log on. And so Microsoft very quickly realized that, yeah, in order to provide feature parity with direct access, which had a device-based connection to it, that they needed to come up with some sort of solution. So they built this device tunnel. The device tunnel, I would submit to you, is a supplemental connection to support the user tunnel. The user tunnel is the main access tunnel. The device tunnel is there to support those corner cases where you must have access to a domain controller to process a logon, again, without cached credentials. Sometimes it's helpful for password changes. So if you've issued a password change for a user, whether that's administrative or self-service, those scenarios, you can have an out of sync scenario where you need access to a domain controller to process that logon and recache those credentials. Okay, so in that case, the device tunnel was created. The device tunnel runs in the system context, And as such, it does not appear in the Windows modern UI. So if you look in the notification area, you will not see the device connection. You will only see your user connection. And so many administrators say, well, I'm only using the device tunnel. I'm using the device tunnel by itself, and I would like some sort of visual indicator in the notification area to know that it's connected. And so, or maybe they're just monitoring it because they're an administrator and they want to know that it's actually connected. There is unfortunately no way to see this at the lock screen. That would be really awesome if they did that. But unfortunately, the only thing we have is you can, via a registry setting, set this in the registry, and you can actually view that information, the status information, in the modern UI. You still can't interact with it because it is running a system, but at least you get a visual indicator that the device connection is up. And again, that's just a registry key, which is fairly easy to do, but again, at scale, it's problematic. And so that is once again just a checkbox that we have here in the in DPC.
Yeah, so just showing you there what it looks like, and you can actually now interact with it from the UI, which is nice.
Mm.
And that setting itself is under the device tunnel settings here, and you have, did I put it in advanced? I did. So it's under this show device tunnel status in UI, and that's just again a enable or disable option.
Yep. And whether or not you show this to your users is up to you, but the option is available. I have had customers say, well, the user shouldn't know or care about the device tunnel, so we don't want to show it to them, and that's the default. But then I've had other customers who, again, either maybe they're just doing a device tunnel only, and we don't recommend that, but that's a supported scenario. You can certainly do that. And so if that's the case, then you would absolutely need this feature.
Lovely, and that's the end of those ones, but we've got a couple of questions coming in, I think.
And we did manage to leave a decent amount of time.
Yes.
For Q&A.
So some users get a disconnection randomly. The event on the server seems to indicate that it was a user request. Once a user gets an issue, generally a reboot is needed, then everything is okay. Is there any way to reset the network stack from the user end without needing a reboot?
Good question. I'll take a stab at this. So connectivity loss for Always On VPN seems to be a fairly persistent pain point. The challenge is that Always On VPN is very sensitive to the underlying connectivity, right? So if there's challenges or issues, problems with the underlying internet connection, then Always On VPN might simply be the victim, right? So we see a lot of errors, like I think it's an 829 error, where it just basically says that the connection dropped, the VPN connection dropped, but there's no indication why. So in that scenario, if it says it was the user, it could also just be a red herring too. It could simply mean that the underlying internet connectivity was lost, even briefly, and then the VPN connection drops. Now, in theory, Always On VPN is always on and it will reconnect. There are, I don't want to say known issues or limitations, but in my experience, I have seen that does not work reliably, where I have absolutely watched this before. I have a connection, the internet connection drops, Always On VPN drops, of course, that's expected. Internet connection comes back up, and Always On VPN just sits there and stares blank at you, right? Where it doesn't attempt a reconnection. So in that scenario, it seems to be something or a problem or issue with the reconnect logic that doesn't trigger that. Sometimes just disabling and re-enabling your internet access, so like just toggling the internet interface, whichever one that is, Wi-Fi or Ethernet, will trigger that. But I have absolutely seen sometimes where you either have to launch the connection manually or you reboot and let it go through the whole process again. Unfortunately, I don't have a good answer for those. It's something that it's not super common, but some of my customers are struggling with that. I don't know about you, Leo. Have you seen anything with regard to that?
Yeah, certainly seen a few places where that's unfortunately being the case. Normally, I find we encounter it more often when we're like heavily testing things, or we're dropping connections, or we're reconnecting repeatedly in a short space of time. And I think sometimes the
I agree.
underlying VPN adapter networking stack is not bug free, shall we say?
I agree. I agree.
Unfortunately, reliable replication of that stuff is very challenging. If you
Hmm.
do have a reliable replication of that, I would strongly urge you to reach out to Microsoft with a Microsoft support case, as they may be able to, if you're able to reliably recreate it, then they may be able to debug it
Hmm.
and ideally offer a fix. But that
Hmm.
when it's just the problem with a lot of this stuff is environmental and ties in a lot with the way that the network was dropped and how it was dropped and where in the chain it was dropped, whether it was your
Hmm.
local Wi-Fi, whether it was the ISP going out, whether there was a blip on the load balancer. The other thing, when it comes to this kind of thing, I have seen it where the load balancer caches the connections, and like the connection between the RAS to the load balancer stays up, or that one part of it thinks it's
Hmm.
still connected, and then it won't reconnect properly because of that. So what you may want to look at is potentially whether clearing the cache on the load balancer helps.
Hmm.
Um, but
And
that's
the
not
cache, you're talking about the state table, the NAT state table, right?
yes, yeah,
Yeah. Okay. Yeah. Yeah, and that's more of a challenge with IPv2, certainly.
yeah,
Less of a problem with SSTP because it's TCP based. So with that, load balancers can send a reset and basically forcibly disconnect the client, and the client at that point knows, hey, I was rejected hard. I'm going to reestablish this connection. With IPv2, it can get into that zombie state where, and I've seen this before, where the client is trying to keep its connection open, so it's sending it to the server. The server has long since dropped it and says, I don't have this connection, so it just ignores it. It doesn't send anything back, it just ignores it. So you can get in that state where you have to wait for NAT timeouts. And the real problem is kind of a circular challenge here, is that you keep sending your endpoint keeps sending packets, which keeps the state alive in the router, or the well, the router, firewall, or even the load balancer. But the workload itself, the actual server where that request is coming, doesn't have that, so it just ignores it. So it can be real challenging, especially for IPv2.
yeah. So we've got another question in kind of a similar vein.
Hmm.
AOVPN what seems to work fine for us. Only issue with connecting is from staff who are Sky broadband customers. Have you heard of this before? So
Yes. So what I have heard is that if you're on a mobile carrier, some of those mobile carriers will use IPv6 exclusively on their network. So they have no IPv4 on their carrier and mobile network. Now, of course, they still need to provide V4 IPv4 access because the internet is not entirely IPv6 yet. And so what they actually do, some of these carriers and even some ISPs do this as well, is they will use IPv4 transition technologies. So they have a native IPv6 network and they provide IPv4 as a service. So you have an IPv4 overlay on an IPv6 underlay. Some of those technologies that they use are things like DS Lite or 464 XLAT, and some of those can be problematic for VPN, especially IPv2. So that is not unheard of. There are ways to there aren't any good ways to work around this, unfortunately. I think this is just a limitation of the way they're doing this. You know, you can try to know if it's a problem related to that specifically. You can try temporarily disabling IPv6 on those adapters to see if it works more reliably. I wouldn't encourage you to do that as a general practice, but for testing, that might give you an idea. You may need to open a support case with your ISP and have them look into it, because maybe they have something that enables you to work around that. But unfortunately, it seems to be an increasingly common challenge. How about you, Leo? Have you encountered that as well?
Yeah, I don't think I've only heard of one person explicitly calling out Sky, and it might be the person asking the question. If not, there was someone else asking the same question. I've not had anything confirmed from anyone in terms of Sky are particularly bad at it, or having issues.
And by the way, just to add to that, I don't know anything about Sky specifically, but the fact that it is a specific ISP, I've had problems in Europe with a couple of different ISPs there that we ended up identifying that as the source of the problem. So it just sounds very similar to me.
Yeah. And I think that a couple of other people have had some issues, but they got around it by setting the MTU functionality.
Oh, good. To know.
So that's not something that is offered in DPC today. It is in the version that is currently undergoing testing, and we're hoping to get out relatively soon. So again, I really would not recommend modifying the MTU, which is effectively the packet size. I really wouldn't recommend it for most people. But again, just like the disabling of the IPv6 piece, it doesn't hurt to test it on a couple of devices and see whether that improves anything. And if it does improve things, then please do reach out to us. We would love to know, especially if it is around specific ISPs, because I can assure you that we've got customers on them and many more. So the more that we can understand what is working or what's broken on specific ISPs, the better. So the next question. So we started to use AOVPN recently in our organization, and we noticed mostly users who are on Virgin have issues connecting to VPNs. So the solution sometimes is to reboot the router and sometimes change the DNS to Google. Any suggestions or advice?
So I suspect that the VPN protocol that you're using is IKEv2. And as I had mentioned previously, IKEv2 suffers from some operational challenges and limitations. And one of those is it does not play well with some NAT devices. Most commonly, consumer grade firewalls that are sometimes provided by ISPs. So that is not unheard of, where you have an IKEv2 VPN connection and you have to reboot your router or or switch to another network. So in those scenarios, if you can, would encourage you to switch to SSTP, because it's far less problematic in those scenarios. But if you must use IKEv2, it's a limitation that you'll have to live with, because it's just really it's a limitation of consumer grade home networking equipment.
Yeah, the other thing that I might suggest on, especially around Virgin Media, is that to maybe start tracking what home hub the individuals are using, because my understanding is that the latest home hub, the Home Hub 5, I think is a far better piece of equipment than some of their older units.
Good to know.
So sometimes the user tunnel becomes non-functional, even though it shows as connected. So the user does not know they can't use internal resources until they need something. Is there any way that they can be alerted? Also, if the tunnel does drop, can an alert be displayed on screen for Windows 10?
Good question. And once again, okay, sounds like we're beating up on IKEv2, but this is probably an IKEv2. So based on my experience, all of these problems are really IKEv2 specific because of the limitations we've talked about, and SSTP is far more reliable and stable in that scenario. So again, if you can support it, would encourage you to switch to SSTP. Other than that, so I would say I'm not aware of any way to do that. You would probably have to build something. I don't know if you've ever had any thoughts about adding that to DPC, Leo, but you'd probably have to do some sort of liveness check from the client, and then, I mean, technically speaking, you could do it, right? Some sort of liveness check to like a domain controller, much like the NLS, right? What are your thoughts?
Yeah, it's It's something that we are considering from a DPC perspective. It's not that simple, just because of the way that historically we have said DPC does not touch connectivity. We are only a profile management piece, and that means that we get away from the whole it started up there, it didn't start there. It's like there's literally no code in the product that can touch any of that stuff.
Got it. Yeah.
We did recently start to introduce some elements around, I think it's forcing the disconnections under certain limited circumstances, at least in the testing branch. So creating a detection and then forcing a disconnect is not out of the question. It's not the highest priority, but it is certainly something that we're mulling over in kind of the back of our heads to see, because something like this could, we do see a customer need and advantage of that. It's just how do we do that safely and intelligently, because the last thing that anyone wants is for DPC to have a bug in it and suddenly we start wiping out everyone or start auto disconnecting everyone's connections. So is it possible to clear stale disconnected devices or user sessions on AOVPN without rebooting AOVPN servers? I think you've got a script for that, don't you, Rich?
Absolutely. Yeah, go to github.com/Richard Hicks, look in the AOVPN repository, and there's a script called remove VPN connections, and there's I think there's two different ones. There's one for stale and then there's one for duplicate connections. So I had a customer who had a bunch of oddly a bunch of duplicate connections, so I ended up writing some code to address that. And so and then I have another one for stale connections. So you can adjust the value if you can set it to 24 hours or something like that, and it will basically go through all of the connections on the server. Anything over your specified period of your threshold will be removed. So, and then you can just run that as scheduled task daily if you like. So, but yeah, that exists. Just look in the GitHub.
You helped us set up our AOVPN environment a while ago. Is there any way to import our current config, etc., or would we need to start again if we switch to DPC and manually set up the same settings? So there is no direct importer for the DPC from like RAS phone connection, but most of the settings should translate over relatively simply. And a lot of the help files will often kind of reference their kind of original Azure names. Sorry, I've got cloud on the brain today. The original AOVPN names in them. So a lot of them, especially, will also be marked as required. And you'll have examples in these things. So you do have to start again. If you are interested in it and you haven't already purchased the product, we'd suggest that you get a trial of it. And if you are kind of struggling with which settings specific things relate to, then you can absolutely raise a support case as part of that trial to kind of help you get involved or get you up and running with it.
Good deal.
And we've had issues with ISP doing ISP side security filtering, e.g. PlusNet. We had to advise users to disable the setting on their customer portal. So I think that's just someone just...
yeah, interesting.
Yeah, that's certainly good to know.
That's, yeah, definitely good to know.
And have you encountered ISP DNS hijacking causing connectivity issues? For Sky, it's possible to add your VPN server to the broadband shield, which can improve connectivity. That is good to know. And they've put a link to an article on DNS hijacking.
Very good.
Which includes Virgin Media. So the person who was talking about issues with DNS on Virgin Media, you may well want to check this this article out.
Great, fantastic.
And it looks like, unfortunately, we are out of time.
Mm-hmm.
So there's potentially a couple of other questions in the chat, but we'll reach out to you kind of separately on that. But thank you very much for joining. The recording will be made available in the next 24 hours. And we'll also include a list of the links that we've had in the we've put through the chat today as well. So
Awesome.
just like to thank Richard once again for joining me.
Thanks for having me, Leo. This has been great.
Yeah, and thanks everyone for attending.
All right. Cheers, everybody.
Have a good day.